Welcome to educator.com. This lesson is about solving inequalities by dividing. In this lesson, you will learn to solve inequalities by dividing. When dividing an inequality by a negative number, the inequality sign changes. Applications are for finding the minimum and maximum time needed for a trip. Division property of inequality. When you divide each side of an inequality by a positive number, do not change the direction of the inequality sign. However, when you divide by a negative number, you must reverse the inequality sign. Let me show you an example. If we have 3x is greater than 6, and we divide both sides by 3, x is greater than 2. However, if I had negative 3x is greater than 6, and I divide by negative 3, the inequality sign here needs to reverse. Dividing by a positive number. A hotel elevator has a weight limit of 2,250 pounds. Suppose the average weight of a passenger is 150 pounds. How many passengers can the elevator safely hold? Well, first let's create our inequality. The hotel elevator has a weight limit of 2,250 pounds. So that means at the very most, it can hold this much weight. It could hold exactly that much weight or less. The average weight of a passenger is 150 pounds, and we want to know how many passengers. So I'm going to divide both sides by 150. I'm dividing by a positive number here. That cancels. We have P 2,250. It will go in once, giving us, and that will go in, I believe, 5 times. Let's check it here. Yes, 750. So P is less than or equal to 15. So at the most, 15 passengers can be on the elevator. But of course, less passengers would be fine as well. Now let's try dividing by a negative number. If I have negative 6x is greater than or equal to negative 18, and I want to divide by negative 6, my inequality sign has to reverse. It's a good idea to draw an arrow or immediately reverse the sign rather than complete all the operations, because oftentimes it's easy to forget to reverse the sign since this is a unique situation. X is less than or equal to 3. Now you may not understand why that happens, and the reason is because when you're dividing by a negative number, it is the opposite of a positive, and you're reversing the direction of the inequality. Let me demonstrate by using a substitution problem. Let's suppose x equals 2. Let's compare what happens. So if I had negative 6 times 2, and that holds true for x, this should work out. So negative 6 times 2 is negative 12. Is it greater than negative 18? Yes, it's true. Now let's say that I took the negative 12 and I were to divide by negative 6, as I did above here. But this time I'm not going to reverse the inequality sign. And let's see if it still holds true. Negative 12 divided by negative 6 is a positive 2. And negative 18 divided by a negative 6 is a positive 3. Now as you see, I did not reverse the sign here. So it's no longer true. It's now false. 2 is not greater than or equal to 3. Now let's go back to the same problem. Negative 12 is greater than or equal to negative 18. And this time I'm going to reverse the sign when I divide by negative 6. That's going to be 2, reverse, 3. 2 is less than or equal to 3, so that is true. So once again, the reason is because when you divide by a negative number, which is the opposite of a positive, you're moving in the opposite direction on the number line. So in order for your inequality to stay true, you must switch the inequality sign. You can use substitution to try out different scenarios. Here we took the top inequality, substituted 2, and found that it held true. Then I divided by the negative numbers without reversing the inequality sign, and we found that it no longer was true. Dividing by a negative number. Let's do some more. Okay, negative 3t is greater than or equal to 51. So the inverse operation of times negative 3 is to divide by negative 3. And once we've divided by a negative number, the sign must reverse. So t is less than or equal to negative 17. So as I said before, it's a good idea to draw an arrow or to reverse the sign right away. Sometimes people prefer to circle the symbol. So for example, I'm dividing both sides by negative 8, and I'm going to circle the symbol to remind myself. That becomes positive, and the symbol switches around to 7. So m is greater than 7. A photo album page can hold as many as 8 photographs. You have 395 photographs to organize. How many pages do you need? So each photo album page can hold 8 photographs. And you have 395 photographs. So that means you need to figure out how many pages you need to have to put into that photo album in order to fit all of these photographs. So let's take 8 times the number of pages should be greater than or equal to 395. Because 8 photographs per page should be more than enough to hold the 395 photographs. So you could always have extra space, but at the very minimum, you want to have enough space for the 395. So we're going to divide both sides by 8, and p is greater than or equal to, let's do our division on the side here. 8 goes into 39 4 times, which is 32. And 75, it goes in about 9 times, so 72, remainder of 3. Okay, here we need to think about what our division means. This means 49 full pages. However, there are 3 photographs left over. And we know that we don't want any remainders. We'd rather put in an extra page than have to throw out our 3 photographs. So instead of 49 full pages, we're going to have 1 extra page for these 3 photographs that are left over, making it 50 pages. So how many pages do you need? At least 50 pages. So in inequality problems, it's very important to think back to the problem and think about what the numbers are saying. In a normal problem, you may be able to have a remainder of 3, but in an inequality problem, when you want to make sure that all the items are used up or you have space for all the items, you need to think about your remainder being an extra whole number added on. A table in the banquet hall can sit 6 people. There are 365 people attending the banquet. How many tables need to be ordered for the banquet hall? So each table is able to sit 6 people. So we're going to say 6p. There are 365 people attending the banquet. So we need to have more than enough room. We could have exactly the same room, but we can't have any less. So it's going to be greater than or equal to. So we could have an extra table, that wouldn't be a problem, but we can't have less. So it's going to be 6p is greater than or equal to 365. I'm going to divide both sides by 6 here. Goes in 6 times perfectly with a remainder of 5. 6 won't go into 5, but we need to think about this remainder being 5 extra people. Well, we're certainly not going to kick out those 5 extra people, so let's take 60 tables and then plus 1 more table for those 5 extra people. And there'll be an extra seat, but that's fine because we can accommodate all 365 people. So that means we will need 61 tables ordered. Negative 0.5x is greater than 18. Now let's return to dividing by negative numbers. So I'm going to divide both sides by negative 0.5, negative 0.5. And I like to draw an arrow to remind myself that that inequality sign is going to be reversed due to dividing by a negative number. That cancels. X is less than now 18. I know my answer is going to be a negative, so I'll put that in. And 0.5 I can't divide, so I'm going to move it once. So move it once. 5 goes into 18 3 times, 15, and it'll go into 30 6 times. Exactly. So x is less than negative 36. So there are a lot of things to remember here. You need to remember to reverse your sign and that you were dividing by a negative, so your answer had to be negative. It's a good idea to first write down the sign reversed and first write down your negative so that after completing the calculations, you know that you haven't forgotten anything because you took care of the extra details ahead of time. A crane can safely carry as much as 8,000 pounds. A crate weighs 60 pounds. At most, how many crates can the crane safely lift at one time? So the crane can carry 8,000 pounds. That is the most. It can carry exactly 8,000, but it can't carry any more. So at the most, it can carry 8,000. A crate weighs 60 pounds. At most, how many crates can the crane safely lift? All right, so 60 pounds per crate. 60 times C, C being our different number of crates. I'm going to divide both sides by 60. I'm dividing by positive, so there's no need to reverse the sign. And here, just to make the numbers a little easier to work with, I'm going to cross out the zeros. Basically, what you're doing is dividing by 10 when you get rid of a 0. Just helps you to make the numbers smaller. So then we have 800 divided by 6. We'll go in once. Into 20, it'll go 3 times. And into 20, it'll go 3 times. And here we see a pattern. What's going to happen is that we're going to have a repeating decimal. But of course, we're not going to take a crate and cut it into a third. That's what this 0.33 means. So instead of making an extra crate, like we did with the banquet hall, we're going to just take that extra weight off because we don't want the weight to exceed 8,000. We want to keep it under 8,000. So we're going to say 133 crates. So at the most, 133 crates can safely be lifted. If we were to make it 134, that would go over the 8,000 limit. Thank you for watching educator.com.